Today is day 3 of my vlog. However, I just had my weekend. So there was a lot of studying that went on over the weekend, and I have a lot of thoughts. Thoughts? I've got them. First thought, teaching yourself something is difficult. That is, that completely, it feels like it's from scratch, even though I clearly remember things from the first and second time around with this. Teaching yourself something from the very beginning, not easy. So I did watch more videos on Khan Academy, and one of the things that we were supposed to do was estimate the tangent line, the slope of a tangent line of a curve, and I was super good at that. He did a couple of different example problem videos, and I was like, it's this, it's that. And I was like, God, I'm so brilliant at this. This is so good. I'm amazing. Um, One of the other things that they did in the videos was say, okay, so if here's a point and the slope of the derivative of that point is equal to this. And I was like, well, that's just the slope. That's this. You just gave me a point and slope and asked me to figure a line. That is algebra 1. And then I had a whole moment where I was like, is calculus algebra 1? No, it's not. This is actually something that happens in math a lot, and that I've noticed as someone who teaches multiple math classes. Uh, things that we learn in Algebra 1, we do more in geometry and then more in Algebra 2. We learn the unit circle for the first time in geometry and then build on it more and more and more and learn how to use it. And eventually there's a point where students are expected to have it memorized, but that point absolutely does not happen in geometry the first time you need to know it. I actually don't have the unit circle memorized. I just have tools to be able to figure it out. So you would tell me find sine of 210, and I would have to sit there and use all of my little tricks to figure out what that was. So it's not exactly memorization. It's just figuring it out using the patterns, but that's neither here nor there. The point is that this algebra 1 type of question is using calculus principles to get us to that question, right? Because in algebra 1, if I said to you, here's a point and the derivative of the tangent at that point, you would go, what? What? And not realize that that was a slope. So that is math. That is how math works. I did end up, and I think I brought this up before, but I don't recall exactly, but I did get sort of confused. No, I did. What I brought up was that I didn't understand, I only understood that the tangent line slope of a quadratic, right? Because like the derivative of x squared is 2x. And in my head, the line is just 2x. But that's not what it is, right? So any x value that you plug in to that value is what the slope is. So the slope at 5, where the x value is 5, the slope of the tangent there is 10. So that was a logical thing that I was missing, but that makes higher level derivatives make more sense. If we are finding the derivative of a polynomial with a degree of 4, then our derivative has a degree of 3, but you still have to plug in an x value and find a number, and that is the slope of the tangent. So that was good because I kept thinking, how is it 2x? How is the slope 2 everywhere? Because 2x is the equation of a line. It's y equals 2x plus 0 if you really need your intercept in there. So I unconfused myself about that. That is a good thing. I also realized, because in my last video, I talked about how I think about the limit going to infinity for a fraction dividing by 0. As we approach 0, the limit approaches infinity. The other limit that I use a lot, but I didn't think of, are asymptotes of a graph, right? So the asymptotes are limits. Because as you know, if we have a curve and it is approaching an asymptote, as you go towards infinity or towards negative infinity, your your line, your curve is approaching that limit, but never reaches it. So that's another limit that I use in my life a lot. And what is also interesting, so I think the first time that students have to do, figure out their own asymptotes is in Algebra 2 when we were learning rational equations. There are asymptotes at what makes the bottom of equation 0, that's your vertical asymptote. And then there's different rules for horizontal asymptotes depending on like what the degree of the top of the fraction and the bottom of the fraction are doing, right? So if the degree is the same, it's one rule, and if the denominator's more, it's one rule, and if the numerator's more, it's a different rule. So we have 3 different rules depending on the degrees in relation to each other, right? So blew my mind. Same thing we were just talking about. The rules of the horizontal asymptotes of rational equations are the same thing as the limit. I wrote this down, this is in my handwriting, as the limit as approaching positive or negative infinity. They are the same. So these rules that so students are finding limits in these problems, and you're using these exact same rules because the limit is the asymptote. And you learned those rules in Algebra 2, and now we are applying them to calculus. Understanding things, figuring these out. So I am understanding these concepts, but I'm also struggling to do the problems, which this was a huge issue that I have in physics. Physics confuses me. So they'll be like, mass equals force equals mass times acceleration. And I can do a basic problem where you're like, find the force, here's the mass and acceleration. I got that. But then they just start throwing these more complex problems at you where you have to use your brain and apply things. And I just feel like, well, I needed an example problem. I can't just figure that out of nowhere. How did I get all these things? So that is something that I find confusing in physics, and I'm starting to have that same problem in calculus right now, where I read the thing, I watch the videos, and I go, okay, I understand what this is telling me, and then I look at the problem in the book and I think, I don't understand how to do that. But I think that part of that is practice, right? I think part of the reason that I know how to do all of math from algebra 1, geometry, algebra 2, and into precalculus, the reason I know all of those is because I have done them and I have practiced them year after year after year as I teach them to students. So I'm missing the practice here and not having a hard time figuring out how to do the problems. So yesterday or the day before, previous video, we discussed the tangent problem. And the other thing we have in calculus with derivatives is the area problem, which is the area under a curve. And so I know I brought that up in my things that I know video, and I'm sort of starting to understand that more. That has to do with a summation situation where we're adding a bunch of things together. Okay, so we have a curve. I'm gonna draw my curve. Ooh, here's my curve. It looks like a bell curve. It wasn't supposed to. I don't know what it's supposed to look like. And we can estimate the area of this curve by like making these, blocks, right? And we can get a more accurate area if the blocks are smaller. And the smaller we make the blocks, the closer we are to having the area. So then using the same logic as we had for the tangent problem, where it gets infinitesimally small. Did I say it right this time? Questions. As we make those boxes under a curve incredibly tiny as they approach 0, then we have the accurate area under the curve. So the logic is the same in terms of we are approaching something that's so tiny that it almost doesn't exist. And that's how we get the accurate thing. Now, I know that we have to use sigma notation to figure that out. We are adding a bunch of things together. We're adding together all of those little boxes, but that's about as far as I've gotten on this. I don't totally understand. So my next plan are to do more research and more problems on that, on the area problem, and why calculus helps us figure out the area under a curve. So to sum up today, let me look at my notes again, because I said it was going to be a lot. I knew it was going to be a lot. estimating slope of a tangent, nailed it, incredible. I figured out what a derivative is more. I figured it out more. Asymptotes, they're limits. Asymptotes are limits. And doing problems is difficult. And now I'm on to the area problem, meaning the area issue, the issue with area and how that relates to calculus. So I appreciate you all who have watched this and are joining me on my journey of figuring out things using my brain skills.